Hello, my name is Matt Zamudio, and this video is going to be what I hope will be a kickoff of a series of videos talking about some things around Unix and Slackware Linux. I created a video a short time ago that started out talking about some Slackware topics, including the TWM window manager, and it turned out that I kind of rambled and went went on to a few different tangents in that video and covered a ton of stuff. Turned out to be over an hour long, and I think that hampered the number of people that were willing to view it. So I'm going to try to stick to topics that I can cover in maybe 15 or 20 minutes, and hopefully that's a little bit more palatable for people to watch. So, a little background about myself. I'm a software engineer. That's my day job. And my sensibilities and mindset are very much centered around the Unix-like computing experience. I used quite a few different varieties of Unix, and have done so for quite a long time, since late 80s. And then in 1993, late 1993, I think it was November, a buddy at work turned me on to this thing that was new at the time called Slackware Linux. And that was my first exposure to Linux. And I've been using Slackware ever since. I've tried most of the other significant distributions. Oh, and quite a few insignificant distributions as well of Linux. And I've tried to always give them a fair chance to that I could be kind of get the idea of what the user experience is really about with them and all that. But I always keep coming back to Slackware. So one of the things that I want to try to do in this video series is I'm hoping that to provide something a little bit different than what you might find in other videos on YouTube around computers and operating systems and Linux, or all these different kinds of topics that I'm going to talk about. And the difference is, I think there's a certain kind of pattern or theme that I notice in many videos, most videos that I've watched, and I'd like to kind of do the opposite of what this pattern or theme indicates. And the people doing these videos usually seem to present it from a perspective of being really excited about how much you get out of the box with a particular distribution of Linux, or whatever they happen to be talking about. It's and I guess focusing more on the Linux specific videos here. The people making the videos are really focusing on how much software comes with the distribution, the kinds of things that they like about whatever they're presenting being really large in how much it provides. A lot of times it's in terms of eye candy, or how much stuff it will do for you, that how easy it makes things, that kind of stuff. And what I want to do is I want to focus in more on core concepts, especially with the notion that how much can really be done with very little. So hopefully that's clear about the different tack that I want to take on these videos. So the other thing I want to talk about briefly here is I think what really motivates me to talk about Unix and Linux is, for ever since probably in the whole history of computing, there's a tendency to compare one platform to another, to compare one approach to another, and certainly some of that stuff is valuable because there are technical merits that can be found in various places, and we always want to pursue technical merit, I think. But in particular with when we think about comparing Unix and or Linux to Windows, there, I think there's a lot of problematic aspects of how this is done quite a bit. So, and I kind of want to address some of that, I think, with kind of where I'm coming from with these videos, and I'm going to try to clarify a little bit here. So obviously, most people, ever since the personal computers got to be kind of headed into ubiquitous territory. In other words, they're very common. People can afford them. Basically the masses started getting much more involved with computers. Um, there's really no question that Windows has dominated in terms of per capita what people are familiar with. Most people are familiar with Windows. Um, and so I don't think it's a mystery why there's a tendency for a comparison, especially if you're going to look at Unix or Linux as an alternative. The comparison kind of has a tendency to start out with here's the Windows experience, the experience you would have using Windows, which again most people are familiar with, and then let's start with that as the expectations, and now let's look at the alternative. And the danger there is there's so much difference between where the strengths actually lie and where the actual focus and direction of the evolution of the respective platforms. There's such a difference in those things that it's not fair to compare the Windows experience to the Unix experience, especially if you start out with establishing that the Windows experience is what your expectations are. So we really have to we kind of back up in scope, and we have to take a look at some real fundamental differences, and some of these differences are even precursors to even thinking about the details of the different platforms. It's actually in terms of philosophy of what computing is about, and what are the best kind of computers give us this kind of virtual toolkit, and what's the most effective way to leverage these kind of resources. So I mean, it gets into some philosophy and stuff. So I want to cover some of that too. Okay, so I want to start out talking about Unix a bit. So Unix has been around far longer than Linux has, and I may make another video that goes a little deeper into what I think about the relationship between Linux and Unix. And there's quite a bit of if you talk to people in the Unix and or Linux worlds, there can be quite a bit of debate around the topic. What's the relationship there and everything? I don't want to get too deep into that now. I'll make another video about that. But suffice it to say that Unix has been around a lot longer than Linux has. And I will put it forth that Linux is first and foremost an attempt to port or migrate the Unix-like experience to the personal computer. So Linux really is, at its origins and in the spirit of its intention, Linux is basically an extension of the Unix-like experience. So let's talk a little bit about what's core to Unix itself. If you talk to people that are really into Unix, I think probably the most common answer or the most consistent answer that you'll get from almost any Unix person is that a core of the Unix philosophy or mindset is that our use of computers should involve tools and further tools of a particular nature. And the Unix concept of tools is that they should be narrowly focused. They only do a certain amount of functionality, but they're supposed to do it very well. And that's part of the narrow focus concept. Is the more tightly a tool can focus on a particular narrow set of functionalities, the better it can actually accomplish those things. And then, in addition to tools being narrowly focused and really good at what they do, it's also intended or part of the Unix mindset that tools should also be designed to be easily combined so that separate tools can be cooperative. They can be used cooperatively and mixed and matched to perform much more complex tasks uh, based on the fundamental tools that are available to you. So I think that's at least a good place to start with the Unix philosophy. I want to talk a little bit about the Unix experience or the Unix-like experience of using the platform. And this is where you can really start to contrast the Unix experience with the Windows experience. So in the Unix experience, because of the philosophy around tools and kind of how they're made available to the user is expected to be proficient. They're expected to be receptive to finding, becoming aware of the tools that are being offered to them, to examine those tools and gain some fluency around how they're intended to be used, how they can be used, and then and this isn't there's another the further expectation, and it's not meant to be a burden on the user, but it's really meant to be for the user's own good. Is that with the fluency of the tools that are being provided by the platform, the user is expected to then use their own creativity, their own skills to drive their own solutions by creating solutions that combine the fundamental tools at their disposal into the specific manifestations that will solve more complex tasks for the user. So in the Unix-like experience, the user is not passive. They're not just a passenger in the computing process. They're much more in the driver's seat. So to contrast that with the Windows experience, the Windows experience does put the user in a much more passive role in the computing experience, and the user, especially the type of user that is not going to seek increasing their knowledge and proficiency with any particular level of tools that may be provided at various levels of the platform. The less the user is going to seek that kind of development, the more of a passenger that user is going to be in the computing experience. And so where the Unix experience is kind of like the when you're in the Unix environment, there's just this immense array of tools at your fingertips, and you're kind of offered the both the opportunity and the necessity of Here's all these tools. Do create to your heart's content. Solve your problems. Do your work. Here's the tools that you need. Here's all the information you need to learn how to use those tools, and knock yourself out. Um, in the Windows world, in the Windows experience, it's much more like this. It's kind of like um, computers are really powerful, especially when really smart people spend a lot of time figuring out what you might want to do and packaging up a lot of computing um, functionality into a bundle that solves a really complex task for you, and all you have to do is click a button. And that's again where I say that in the Windows experience, the user is much more passive, is more of a passenger, because most of the time, whatever the user wants to do, somebody has already kind of predicted it and packaged it and put it in a form where the user basically uses the mouse and doesn't have to type much in. If they do have to type some stuff in, it's kind of predicted out what they're going to need to type in and when, and uh, that's really what the user is encouraged to get used to. So um, when you look at the difference between the mindset that I've kind of laid out here, I think at least I feel it gets really clear that how unfair it would be to start out looking at the Windows experience and saying, well, this is my expectations of what computers should do, and then turning and saying, let's look at Unix. Oh, Unix sucks because it doesn't match the expectations of that Windows experience. So that was kind of the big point I wanted to make, that when you do go about comparing some of these things, uh, you really have to try to keep in mind what's important in terms of making sure that you're comparing on equal footing, or making a relevant comparison. So another couple of insights or observations. The Windows experience, very graphically oriented. There's a lot of visual stimulation given to the user. The user is expected to be responsive, and also to kind of focus on that visual feedback, and even the interface being primarily GUI oriented, is all about interacting with that visual stimulation from the display. In the Unix experience, graphics are, at least traditionally, graphics are an afterthought. You can use a Unix system to full capacity without ever having any graphics, um, except for text. I mean, the core Unix interface is a text mode interface. So as long as you can read and you can type, uh, that's the core of the Unix user interface. Now, obviously, there are optional um, choices. And again, I think that speaks to the flexibility and power of Unix. You can have a graphical desktop experience on Unix. The key is that that's not intrinsic to where the strengths of Unix are, and it's completely optional. Whereas in Windows, the Windows system wasn't even really built. Uh, I mean, its remote ancestor, DOS, Microsoft DOS, was a text mode environment, but that does not define the current Windows experience. So DOS has pretty much been left to die in the dust, and there are very isolated, or very um, there are scenarios where you can use a console or a terminal in Windows, but it's certainly not intrinsic to the operating system. So, uh, okay, I may want to get into some more about these kind of topics at some point in the future. So I may kind of go down this road this topic a little more in future videos, but I'm going to leave it for now. So let's talk about Slackware a little bit. Slackware is first and foremost a Linux distribution that seeks to preserve the Unix-like experience. So I think it's fair to say that if you were to consider the Unix-like experience independently of Linux, Slackware is the Linux distribution that is the most Unix-like. One of the ways Slackware does that is the team that creates and maintains Slackware retains some pieces of philosophy or basically some policies that kind of reinforce that, and one of them involves respect for the upstream software author's intent. So all of the software outside of what makes up an actual Unix system footprint. So I'm kind of loosely referring to basically application software. Although some of the software is, there's some gray area here. Some people would consider things like LS, basically the programs that make up common Unix command line utilities. Some would consider those part of the operating system. Some might consider them just programs. It doesn't really matter. There's some gray area there. So basically what I'm saying is, and in terms of what Slackware does here, it doesn't make any difference because all of the software is treated the same way. And it's literally, there's a respect for the upstream software author's intent for how the software is to be built, how it's to live in the target operating system or operating environment, et cetera, et cetera. So the Slackware doesn't suffer from a lot of Slackware specific quirks because it really tries to not introduce anything like that. Everything kind of it's like a what you see is what you get form of operating environment. So let's talk a little bit about Slackware's Slackware's identity information. So this is Slackware website. Very clean and Spartan, and that I think that's reflective of Slackware's mindset. I'm gonna talk a little bit about the Slackware build pattern, and so I want to show just a quick little. This is going to be like a total drill down. I don't want to lose you here, but I just really want to show you this. So. Let's see if I can remember where. Let's see. I think it was going to be under packages, maybe. Yeah. So Slackware 14.1 is the. I use 64 bits, so I'm going to go in here. Okay, yeah, this is where I wanted to be. So this is kind of a snapshot of what is on the installation distribution, or the distribution installation media. So if you burn a DVD, this is basically what's on the DVD. So you'll notice that there's a source directory. I actually think the source directory ends up on a separate DVD. So if you download the ISO for the regular installed DVD, it won't have the source directory. It's on a second DVD. But notice in this browse part, the whole snapshots here together. So I'm going to go down into the source, and these are all categories of software packages, and I'm just going to go down into one of them here. And all these directories here, these are every little piece of software that comes with the distribution. Has its own little directory, and I'm just going to pick one here. Let's pick grep. Okay, so grep is a very familiar program to Unix users, and this is The contents of this directory here represent what it takes to build the grep program for Slackware. And this was the actual build materials used by the people that create and maintain the Slackware distribution. They basically did exactly what I'm going to explain here. So this is the upstream source for the program. So the actual author of the grep program, this is the exact source that they distribute. This is it's called a SlackBuild script, and it's basically a wrapper script. And what it does is it's inevitably going to execute the build mechanics exactly the way that the upstream software author, intended for the software to be built. And different upstream authors use a wide variety of tools in their build processes, and so this wrapper script takes care of whatever this particular piece of software uses to build itself with. The SlackBuild script is going to utilize that, and then the SlackBuild script also takes care of some details like what kind of options might be passed, and frequently when building software for a distribution, the creators of the distribution have to make some decisions. What are the options that they want to distribute the software with, and so those options are indicated in the SlackBuild script. So you could grab all of this stuff and onto your machine, and you could run the SlackBuild script, and it's actually going to build the software exactly the way that it was built for the distribution release. That's very valuable. And this whole thing here is reflective of, and this is what I refer to as a build pattern. Slackware observes this build pattern for every piece of software that comes with the distribution, and this build pattern is, I would say, it's very well thought out. It's very, very in keeping with the Unix mindset of having tools be really narrowly focused. This build pattern doesn't try to do a lot of fancy stuff. It basically says we want to build every piece of software the same way. As far as we want to have a tool chain that works for every piece of software, and yet we don't want to mess with the way the software was intended to build very much. So I mean, it's pretty much I would consider it optimal. It's like the minimal amount of wrapping that you would need to accomplish that goal. So it's very clean, very tight, and because it's very simple, clean, and tight, and the entire operating system is built, or the entire distribution is built using this pattern. This pattern is extensible to the user community. So there's a community maintained repository called slackbuilds.org, and this is basically a huge repository of that same build pattern, the SlackBuilds, for lots and lots of other software that is not included with the distribution. So going back here, if you had, let's say you didn't like an option that in the distribution they built grep with an option that you didn't like. You want to change that. Well, all you have to do is remove the package of grep that came with the distribution, download these materials, run this the first thing you'd have to do is go in to the SlackBuild script and change whatever option, or maybe you'd have to add an option or something, depending on, and when you read these SlackBuild scripts, they're not really very difficult to understand. A lot of times software, a real popular pattern for software to be built is using the configure script with a make file, and then so you do configure with some options, and then that creates some information that's used by the make file as you type make, and the make uses a make file that kind of uses all that information to build the software a certain way, and then you do make install, and that pushes the product of the build out into the operating environment's footprint. Well, what the SlackBuild would do in that case is, it calls configure with whatever options the Slackware creators wanted. What if you wanted to change one of those? Well, you would go into the SlackBuild and you'd see where it's actually calling configure with those options, and you change it, save the SlackBuild, and then run it. And it does everything else exactly the same, just makes your little change. And the end result of doing that is a new package, and that package is exactly like the one that came with the distribution, only it has your change. And then you can hang on to that package and use it to install on many systems. You don't have to build it every time. Um, and that's another good point. Is that the way this build pattern works? It puts Slackware in what I would call a very optimal position between two extremes, and those extremes would be represented by something like Gen 2 on the one side, where it's kind of everything has to be built from scratch every time, and their whole build pattern is built around, if you invoke the front end, basically saying what piece of software you want, and it actually figures out all the dependencies based on what you have on your system, and it downloads the source for you, and it builds everything in a potentially very unique environment that consists of what you happen to have installed and what different versions of things you happen to have installed and all that stuff. And that build pattern is so complicated because of everything that it's doing. When I tried to use Gen 2, I had all sorts of problems. Their build pattern is called emerge, and the emerges generally work and are easy to use. You basically type emerge and then the name of the software you want, and it does everything for you. But what I ran into is I would do like I would do an emerge on some little piece of software, and it would have a bunch of dependencies, and some of those dependencies would include upgrades to other versions of software that I already had. And so the emerge would actually automatically go out and download that stuff and build it, and it would break a whole bunch of stuff on my system because the emerge, repositories and the logic that they use wasn't capable of figuring out the particular combinations of stuff that I had. And it's just isn't. It's too big of a job for a build pattern like that to be perfect all the time. So it broke. I had tons of trouble with it breaking all the time. So, and I'm not trying to rip on the people that create and maintain Gen 2. The amount of times that it did work was pretty impressive, and the amount of the sophistication of that build pattern is impressive. But like I said, I just think the nature of the build pattern is kind of a losing battle. So unfortunately, I think Slackware's pattern is much better. So that's the one extreme, and then the other extreme would be the complete. I would kind of call it the blind binary pattern, where not only are you installing everything from binaries, but you have no idea how they were built. You're basically trusting some upstream source that built the software. Who knows what kind of conditions it was built under, what was present in the system, etc. And there's always the concern of using software that someone else built. Did they make a mistake of some sort that ends up leaving you vulnerable to something? Did they include something that causes a security problem for you, or maybe even they're under attack. Somebody sneaked something malicious in to their software building environment, and you're using the package they built, and your system is going to become contaminated, by what they built. So there's always that possibility, but that isn't necessarily the only consideration. It's just that this kind of blind binaries from who knows where Um, or you may know where they come from, and you may have confidence in that provider, but there's still the whole thing about, um, they did build in a particular environment with a particular combination of stuff. You know, really, who knows how close that is to what you actually have. So there's always that. So anyway, so there's two extremes. Um, the build everything from scratch every time, and the blind binary. Slackware is in what I consider the optimal position between those two extremes, because you get to build the software yourself. So you're not going to use packages that other people created, but you only have to build it once, because the target of every build is a binary package that you can use, from then on. So and to kind of sweeten the pot there, the build pattern is so simple, anyone can do it. I mean, you download the stuff, you run the SlackBuild, it makes a package, you install a package. It's to me, it's quite beautiful. So that was why I wanted to talk about that. And again, I think this is very much in keeping with the Unix mindset. So I think that's what I want to cover in this first video. Keep an eye out for some more upcoming videos, and I'm going to get into some other possibly more interesting topics. I hope I didn't ramble a little too much on the. I know these are kind of deep topics sometimes, but we'll try to get into some more fun stuff coming soon. So thanks for watching, and I will see you next video.